Okay, the value of y varies directly with x. When you do this, okay, these are called direct variation problems, and it's pretty much the slope formula without, see, y over x is your slope y-intercept form without the y-intercept, okay? So when you do this, they're looking for an equation here. So you're going to go y over what? When you substitute, you're going to substitute these two right here first. 30 over x. So you put it in your calculator. So control divide. And I can control divide again, so I can put the 20 over 3 divided by 30. You see it's 2 over 9. So I have y is equal to 2 over 9x. Okay. Number 2, the value of y is directly proportional to the value of x. Directly proportional. It's a sort of same thing as say varies directly. Okay, so y equals y1 over x1. I'm writing down the formula, x. Okay, now I substitute. When I substitute, okay, here they give me the x, okay, so I know one of my y's there. When I substitute, the two things that go together, I substitute first 35 over 140, and then x is 70, so this is 70. I put all of this into my calculator to find y, and my answer would be 17.5. Number 3. Okay, in an electric circuit, the voltage resistor across the resistor is directly proportional. Okay, again, the word direct. If the current is 17 amps, so I'm going to let my amps be my x and my voltage be my y. So they give me x here, okay, amps here, so that's x, okay, and it says how many voltage, so that's going to be my y. Y equals y1 over x1 times x. Okay, if you look at this, y is equal to 480 over 12, and since 1.5 is my amp, I put times 1.5. I'm going to put that in my calculator. Control divide. 480 divided by 12. Oops. Delete, delete, delete. Typed it in wrong. 480. 12 times 1.5. Enter. My answer is 60. So it's 60. The mass of a substance varies directly. See how they use different words. The volume of 100 kilogram of a substance is, so I'm going to just say first, this comes second, x, y. What is the volume? So they're asking for volume. Okay, in liters. See, liters, so this is going to be my y of 3.2 kilograms. So that's going to be my x. Okay, so y is equal to, so these are the two things, 80 over 100. Okay, they're asking for y, so this is 3.2. Okay, so calculator, control divide, 80 over delete. I already did control divide. what was that number again? 3.2. So their answer is 2.56. Okay, the table shows the population P of mice in a field at the end of, okay. Based on the table, what is the population of mice in the field at the end of 8 months? Okay, so we look at this and we can see that there's increasing by 1. So all I'm doing is extending the table, 7, 8. So if I look at here, what happens from 6 to 12? You can either add 6 or you multiply by 2. Here, it looks like they're multiplying by 2. So I'm going to extend this. 96, 192 times 2 again. Okay, times 2 again, I get 384. Times 2 again, I get 768. Times 2 again, I get 1536. Okay. You just gotta see the pattern on the table. Okay. Alright. The dishwasher is loaded with the same number of dishes every time it is used. The table below shows the number of dishes washed as a function of the number of times the dish washed. Okay, so what we have to do is figure out what happens here. Okay, so I can go into my calculator and say 104 minus 52, enter. So the increase is 52. Plus 52 maybe. Let's try the next one, okay? 104, 156 minus 104. This is 52. Okay. So 208. So it looks like it's 52, okay? But now we want to use when the dishwasher is 9 times. Okay, so if you look at here, it's going up by 2. It's going up by 2. So if I add 52 again, okay, it'll be 260. But I don't want 10. I want 9. Okay, so instead of adding 52, what we really want to do is add half of 52, which is 26. Okay, so I have 208 plus 26. 14, 3, 234 should be our answer. Okay, the first 5 patterns in the figures are shown below. Each figure is made up of identical circles. So, first thing we need to do is make a table. Figure, okay, which is my N. Okay, and circles. I call it C, okay, 1, 2, 3. 1 has 3. 1, 2, 3, 6. 8. 2 has 8. Then 3, 4, 8, 12, 13, 14, 15. 3 has 15. 4 has 2, 4, 5. 10, 15, 20, 24. And 5 has 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 30. 35. Okay, so when we do this, okay, we can just basically use these numbers right here and check our calculators. Okay, so I'm going to check the first one. This time I'm going to go into my graph. Okay, doc, file, new document, no, add graph. So my first equation, I'm going to go x squared plus 2x, okay? Instead of using, remember, when we go there, we use x instead of the other letters. X squared plus 2x. Enter. You can use graph enter fields, but this one right here, because I know it goes 1, 2, 3, 4, 5, I'm going to go to my table. So I press Control T. Look, 1 is 3, 2 is 8, 3 is 15, 4 is 24, 5 is 35. So that looks like our answer. Okay, the first 5 terms in a pattern are shown below. The pattern continues again. First 5, right? So what I'm going to do is just write down the numbers in table form. And I'm going to use my calculator. Alright, I'm going to get rid of the table. Tab. I'm going to delete this and put in my first equation, which is 0.75x minus 1.25. Okay, 0.75x. Is that right? 0.7x minus 1.25. Control T. Remember, that's not right. I forgot to press enter. Delete, 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 delete. Okay, so I put in the correct formula now, and Control T, 0.5, 0.25. So 0.5, 0.25. So no, that is not actually correct. Okay, I'm going to try this one because these two are negative slope and the numbers are increasing. Okay, 0.25 minus 0.75. So Control T, I get out of there. Tab, change my formula. Delete, 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 delete. 0.25 minus 0.75. Oops, I forgot the X. Very important to put the X in there. Okay, enter. Control T. 0.5. You see, this one is correct. Okay.